Today, I'll be explaining a bit on the refrigerant cycle. First, we will look into the properties of the refrigerant liquid. The refrigerant liquid tends to boil on a room temperature. In some cases, the refrigerant gases condense in a room temperature. Evaporating and condensing took a lot of energy to do both process. Let's do some example by using a gas can. When we push the nozzle, the gases in the can burst out and create a low pressure. The pressure makes the evaporation process faster. Evaporation or boiling takes a lot of energy. You will feel an instant cold on your hand caused by the energy used up for the process. Let's put the liquid in a loop. On the left side of the loop, the energy was sucked in for the liquid to change its properties into gases, while on the left side, the energy was released for the particle to change from gases into liquid. This is the evaporation and the condensation process. Now we are applying pressure to the liquid. When we apply high pressure to the liquid, it will promote the condensation process. And when we apply a low pressure on the liquid, it will promote the evaporation process. Now we apply a condenser and a valve to the loop. The condenser helps to create a constant flow in the loop, while the valve creates a pressure by controlling the flow of the liquid. Now we apply a fan system to the loop. On the left side, the room temperature air was took into this loop and the energy was used. After that, the cold air will release to the outside. While on the right, the room temperature air was took in and the energy released by the loop was took by the air and brought outside.
In this video, we will see on how to describe various processes on a psychometric chart. First of all, let's look on the air heating process and the air cooling process. These processes is described on the horizontal line of the psychometric chart. During the heating process, the dry bulb temperature of the air increases, while the humidity ratio remains constant. Meanwhile, during the air cooling process, there is a decrease in the dry bulb temperature. The humidity ratio again remains constant. Next are the air humidification process and the air dehumidification process. These processes are described by the vertical lines on the psychometric chart. During the humidification process, the humidity air increases, so the humidity ratio increases. But the dry bulb temperature remains constant. Meanwhile, during the air dehumidification process, the humidity ratio decreases. And again, the dry bulb temperature remains constant.